Hello viewers, I'm Dr. L. Prasanna Venkatesh, Department of Mathematics, Satyabama Institute of Science and Technology. In this video lecture, I'm going to discuss on how to solve problems on gamma function. First, let us see what is gamma function. Gamma function is an integral, a special type of integral, which is denoted by 0 to infinity e power minus x power n minus 1 dx, where n cannot take the value 0, minus 1, minus 2, etc. So it's a special type of integral which is defined in this manner. There are various forms of gamma function. The second form of gamma function being 2 times 0 to infinity e power minus x squared x power 2n minus 1 into dx. So either of them can be used as to define gamma function, and there are some associated properties in terms of its values, which are gamma of 1 is 1. Gamma of n is n minus 1 times gamma of n minus 1. In particular, if n is a positive integer, its value is n minus 1 factorial. And third, gamma of half is root pi. These are the important properties from the definition of gamma function. Now let us see what are the properties that may be useful for solving problems. First one being 0 to infinity e power minus x power n dx is equal to gamma of n plus 1. This will help us to find gamma values of some integral given with e power minus x and some power of x. So whatever is the value of power of x, gamma of 1 plus that can be calculated. In particular, if n is a positive integer, it can be calculated using n factorial. Secondly, 0 to infinity e power minus x squared x power n dx is 1 by 2 gamma of n plus 1 divided by 2. This is also a direct result which can be inferred from the second form of gamma function. The next generalized gamma function, or the generalized value of gamma function, is 0 to infinity e power minus k times x power a into x power b dx, the value of which is 1 by a into 1 divided by k power b plus 1 by a, gamma of b plus 1 by a. And this result can be derived using a suitable substitution of t is equal to kx power a. By substituting this, we get this result. The last one, for which there is no proof, we can take it as a directly available result. Gamma of n into gamma of 1 minus n is pi by sine n pi, where value of n lies between 0 and 1. Now let us go for problems. Before problems, let us quickly go through the results. First one, 0 to infinity e power minus x power n dx is gamma of n plus 1. Particularly, if n is a positive integer, it can be taken as n factorial. 0 to infinity e power minus x squared x power n dx is equal to 1 by 2 gamma of n plus 1 by 2. Then the general result, and then gamma of n into gamma of 1 minus n is equal to pi by sine n pi. Now let us proceed for problems, how to apply these resultant problems. Even before general application of those results into problems, we will discuss some basic gamma values. For example, gamma of 4. We know if n is a positive integer, we can directly say it is n minus 1 factorial. So it is 4 minus 1, which is 3 factorial. Same way, gamma of 10. Yes, it is 9 factorial. How to calculate gamma of 3 by 2? For that, we have to make use of a result which is gamma of n is equal to n minus 1 gamma of n minus 1. So if you see this result, n minus 1 gamma of n minus 1, taking n as 1 by 2, 3 by 2, you will get n minus 1 as 1 by 2. So gamma of 3 by 2 is 1 by 2 gamma of 1 by 2, or gamma of 1 by 2 into root pi. Now, how to generalize it? Let us say gamma of 5 by 2. Gamma of 5 by 2 same way can be written as 3 by 2 gamma of 3 by 2. And gamma of 3 by 2 can be calculated or can be substituted using the previous result, so that you will get gamma of 5 by 2 as 3 by 2, 1 by 2, gamma of half or root pi. Supposing we want gamma of 7 by 2, you start with 5 by 2 and go up to 1 by 2 multiplied by root pi. This gives us the pattern of calculating odd number divided by positive odd number divided by 2. Gamma values of positive odd number divided by 2 can be calculated using this logic. You start with 1 less, go up to 1 by 2, then multiplied with root pi. Just continuing with this, gamma of 11 by 2. Numerator, positive odd number, denominator 2. Start with 1 less. What is 1 less? 9 by 2. So 9 by 2, 1 less 7 by 2, then 5 by 2, then 3 by 2, then 1 by 2, multiplied by root pi will be its value. Just let us check. 9 by 2, 7 by 2, 5 by 2, 3 by 2, 1 by 2, root pi. Next, we will proceed for negative odd integers in the numerator. To start with, gamma of minus 1 by 2. Again, we use the same rule, but this time we take n as half. If you take n as half, in gamma of n is equal to n minus 1 gamma of n minus 1, we get minus half gamma of minus half. Gamma of half is equal to minus half gamma of minus half, from which we will get gamma of minus half is equal to gamma of half by minus 1 by 2, which is going to give us a pattern in the denominator on the right hand side, with numerator being gamma of half always. Gamma of minus 3 by 2, same way if you proceed. For gamma of half, you can continue up to minus 3 by 2. We will get gamma of minus 3 by 2 as gamma of half divided by minus 1 by 2 into minus 3 by 2. So this gives us a pattern. You start from minus 1 by 2, go up to whatever number for which you are finding gamma on the left hand side. Just check. Gamma of minus 5 by 2 is 1 by gamma of 1 by 2 by minus 1 by 2, minus 3 by 2, minus 5 by 2. Same way, what will be the value for gamma of minus 11 by 2? Numerator gamma of 1 by 2. Denominator will be minus 1 by 2, minus 3 by 2, minus 5 by 2, 7 by 2, 9 by 2, minus 9 by 2, finally minus 11 by 2. So this is how we calculate it. So quickly recalling what we discussed, to find direct values of gamma functions like 4, 10, etc., positive integers, directly you can use factorials. If it is positive odd number by 2, you start with 1 less, go up to 1 by 2, multiply by root pi. If it is negative odd number in the numerator divided by 2, in the denominator start with minus 1 by 2, go up to whatever number for which you are finding gamma value, but in the numerator gamma of half. Right? Now we'll discuss how to proceed for problems. First question. Integral 0 to infinity e power minus x squared into dx. The obvious result we can use is the second one, which is 0 to infinity e power minus x squared, x power n dx is equal to 1 by 2 gamma of n plus 1 by 2. Now quickly comparing this, what is the value of n? E power minus x squared, e power minus x squared matched. There is no x power n term. If there is no x power n term, we can take it as x power 0. Therefore, we can write this as e power minus x squared into x power 0 into dx. Now we can substitute n as 0 and complete this question by taking half into gamma of 0 plus 1 by 2. That is equal to half into gamma of half, or simply square root of pi divided by 2. Hope till now what we have discussed is clear for you. We'll go for one more question of the same type. E power minus x squared, x power 5. Here, clearly n is 5. We are applying the same result to solve the problem. If you substitute n as 5, you will get gamma of 5 plus 1 by 2, which is gamma of 3. Gamma of 3 is 2 factorial. 2 and 2 will get cancelled. We'll get 1 as the answer. It is just a continuation of what we discussed as the first question. A different value of n, we substitute and get its value. Next one. 0 to infinity e power minus 3x x power 4 into dx. How to find the solution for this? There are two ways of doing it. One is direct method, direct substitution method. The other one is what we have derived as a result method. If you want to solve this directly, we need to encounter this 3x. So take substitution t as 3x. If you take t as 3x, we'll get x as t by 3. Then dx will be dt by 3. And as a result of this, the limit values will change. Will not change, but we have to substitute and check whether the limit value changes or not. But here it remains the same. 0 to infinity, still be 0 to infinity. Now substituting all these things in the integral will become 0 to infinity e power minus t, t by 3 whole power 4, dt by 3, which on simplification will give us 1 by 3 power 5, 0 to infinity, e power minus t into t power 4 dt. Very easy to identify. You are just collecting all powers of t, e power minus t dt inside the integral, all the constant terms outside the integral. Constant terms are 3, powers of 3. You have 1 power of 3 in the denominator, 3 power 4. Another one dt by 3. So 3 power 5 is in the denominator, and that is taken outside the integral. And then this integral e power minus t, t power 4 dt, its value is 4 factorial, because we already discussed if n is a positive integer, e power minus x, x power n dx is n factorial. So it is 4 factorial divided by 3 power 5, which is 243. On simplification, we'll get 8 by 81 as its value. This is one way of doing it. Another way of doing the same question is using result method. Whatever we derived as the result, 0 to infinity e power minus k x power a x power b dx will be 1 by a 1 by k power b plus 1 by a into gamma of b plus 1 by a. So if you compare this, k value is 3, a value is 1, b value is 4. So we use the formula. The formula is 1 by a, 1 by k power b plus 1 by a, gamma of b plus 1 by a. If we substitute that, we get this to be equal to 8 by 81. So either way we can do this problem, but whenever you are doing using result, it is always better to write the result and then quote and then substitute the values and get the answer, right? I hope what we discussed in problems on gamma function is clear for you. I hope you would have enjoyed this video, and I'll stop with this and come back with more topics in more videos. Thank you.